number 13 from the PARCC practice test, Algebra 2, paper-based version. And so this one, it says consider the polynomial function. So we have this polynomial function here. And it doesn't look like a polynomial, usually does, but it's a factored out polynomial. So we have a binomial times another binomial times another binomial. And if we were to FOIL this out, and do all that, and then whatever we get there, multiply it and distribute it times this function, we'd end up with a big old polynomial, with a normal looking polynomial like we're used to seeing. So anyway, for part A, what is the y-intercept of the graph of the function in the xy coordinate plane? Alright, so y-intercept, all we do for y-intercept is set x equal to 0, right? So that's what y-intercept means, is we set x equal to 0. Okay, so what I'm going to do is I'm going to plug in 0, right, which means I'll plug in 0 here, here, and here. Okay, so it'll be f of 0, and I'm just going to start. So it's going to be all the normal stuff, but instead of x, I'm just leaving space for a 0 to go in. Okay, so I'm just copying that down, except wherever there's an x, I'm putting in a 0. Alright, now we just evaluate this, and you can plug it straight in your calculator like that, but it's not hard to do mentally, because 0 times anything is 0, so in this first set of parentheses, we just end up with -1. Here we have 0 plus 4, which is 4, and then 0 minus 2, which is -2. Okay, so then we have -1 times 4 is -4, and -4 times -2 is +8. So there's your y-intercept. Alright, so that's the y-intercept for this function. So that's where it crosses the y-axis. Alright, so let's check out part B. Okay, so we have the same function. And part B says, for what values of x is f of x greater than 0? Alright, so now first let's find out where f of x equals 0, right? So I'm going to consider, okay, well, if I want to figure out where it's more than 0, let me figure out where f of x equals 0. Okay, so what I want to do is I want to plug 0 in for f of x. So instead of f of x, I want to put a 0 there. Okay, so 0 equals 2x minus 1, x plus 4, x minus 2. And so just like when we factor quadratics, the reason we do that is because if for this to equal 0, because we're multiplying this times this times this, the only way to multiply and get 0 is if you multiply by 0. Okay, so that's called the zero product property. So in other words, one of these has to be 0, right? Or all of them have to be 0. So either 2x minus 1 has to equal 0, x plus 4 has to equal 0, or x minus 2 has to equal 0. Okay, one or more of those things has to happen for this equation to be true. So now I'm just going to solve all these for 0. So I'd add 1 here. So I get 2x equals 1. And I would divide by 2. So x equals 1/2. So that's 1 0 of the function, or 1 root of the function is x is 1/2. So now I'm going to work with this next equation. So now I'm going to take away 4. So I get x equals negative 4, so there's another 0. And then the last one, add 2 to both sides, so I get x equals 2, right? So those are my zeros. So if I think about that on a number line, negative 4 is furthest on the left, then I have 1/2 somewhere, and then I have 2, right? So I want to figure out in these intervals, where is f of x positive, okay? So remember that f of x is this function here, right? Okay. So what I want to do is I want to plug in values over here to the left of negative 4 and see if they come out positive or negative. Then I'll plug in values between negative 4 and 1/2. Then I'll plug in values between 1/2 and 2. Then I'll plug in values that are greater than 2. Okay. And I'll see if f of x is positive or negative in those intervals. Okay. Because it has to be one or the other, because I know these places that we found, right, are the places where f of x equals 0. Alright, so I'm going to start here. Forget what color I use, but I'm going to plug in a value that is less than negative 4, like negative 5. So I'm going to basically find f of negative 5. So I'm going to do the same thing I did earlier, except I'm just going to plug in negative 5. So I'm going to put negative 5 here, negative 5 here, negative 5 here. And I'm just going to plug it in my calculator. So it'll look like this, 2 times negative 5 minus 1, negative 5 minus, or plus 4, and negative 5 minus 2. Okay, so just plug that in your calculator, and you're going to get, and it doesn't really matter exactly what it is, you just wanted to see if it's positive or negative. And I'm just going to work this out on the paper here. So this will be negative 10 minus 1 is negative 11. Negative 5 plus 4 is negative 1. And then negative 5 minus 2 is negative 7. So that's going to come out negative, right? So f of x is negative to the left of 4, right? Or left of negative 4, right? So f of x is less than 0. Everything that's less than 4, right? Okay, so now let's do the same thing, but this time we're going to plug in something that is between negative 4 and 1/2. So 0 is in between negative 4 and 1/2, so that's an easy thing to plug in. So I'm going to put 0 in here. So it's going to be, and we already know that f of 0 is 8, right? So that means that f of x is greater than 0, right? It's positive, in other words, in this interval. So this interval right here is one of the ones that we're wanting to use here. So from negative 4 to 1/2, right? Negative 4 to 1/2, like B says, f of x is greater than 0. Alright? Okay, and the way we got that is by plugging in something in between these two, which we had done on part A, because we plugged in 0 and we got 8. So we knew that f of 0 equals 8, and therefore f of x is greater than 0 in that interval. Alright, so now we're going to do this. Now we're going to do this interval. So between 1/2 and 2, 1 is in between there, right? So 1's a good number to plug in. So I'm going to plug in 1. And so I'm going to do 2 times 1 minus 1, 1 plus 4, and 1 minus 2. Alright, and I'm just going to do this kind of mentally here. 2 times 1 minus 1. 2 times 1 is 2, minus 1 is 1. 1 plus 4 is 5. And 1 minus 2 is negative 1. So we get a positive times a negative, which will be a negative. So it comes out to negative 5. But negative is the key thing there. So f of x is less than 0. Alright, so now we have one more interval. So over here we just want anything bigger than 2, so we can plug in 10, we can plug in 5, plug in 3. I'm going to go with 3, so I'm just going to do the same thing we did before. Except this time, instead of 1, I'm going to plug in 3. And so I'll get 2 times, put in a 3 there, minus 1, 3 plus 4, and 3 minus 2. Alright, so if I work this out, 2 times 3 is 6, minus 1 is 5. 3 plus 4 is 7, and 3 minus 2 is 1. So that comes out positive. So that means we have f of x is positive for anything greater than 2, right? So x is greater than 2. So here's an answer, and then we decided earlier that that was an answer, right? Because this is where we have positive values for x, and then everything after 2, which means everything where x is greater than 2. So those are 2 answers for 13b. All right. All right, for part C, it's asking what is the end behavior. And end behavior we haven't really talked about in those terms, but basically what they're saying is what happens when you look at a function, what happens when you go all the way to the right, and what happens when you go all the way to the left. So that's the end behavior, okay? So like, for example, if I have a parabola, the end behavior would be as x approaches infinity, f of x also approaches infinity, right? Because the function goes up onto the right. As x gets higher, y gets higher, right? And it goes forever in both directions. And so the same thing as we go to the left with x, y also goes up forever. So as x approaches negative infinity, y would approach positive infinity. Okay, so I just made that I just use that as an example But that's what end behavior is, what happens to the left forever and what happens to the right as it goes on forever. Alright, so this function, we have to kind of think about what kind of function this is, because we know our parent functions, what they look like generally. So now remember, this is a calculator question, so you can plug this in your calculator too and see what it gives you, and that can tell you the end behavior. Okay, but I'm going to kind of show you a way to do it without the calculator. So what I would do is just multiply all of your x's together. So 2x times x is 2x squared. Now I'm going to multiply that by x again, and so then I'll end up with 2x cubed. Okay, now you're going to have a lot of other terms if you FOIL this whole thing out, but the term with the highest exponent is going to be 2x cubed, right? And that makes it a cubic. So remember, cubics, parent function looks like this, right? And it's going to go up and to the right and down and to the right if it's its parent function. So here I don't have any reflection, so 2 is positive, and the x, there's no negative inside with the cube, so x is kind of by itself, so there's no horizontal reflection either. There's no negative inside with the x, and so that means that this function is going to go up and to the right and down and to the left. Okay, so in other words, as x approaches, and let's do this one first. As x approaches negative infinity, so as x approaches negative infinity, y approaches negative infinity. So as x approaches negative infinity, y approaches negative infinity. So it's got to be c or d, right? It's not these ones. These ones will be opposite of what's happening. Alright, so then we got to just figure out what happens on the right. So on the right side, as x approaches positive infinity, y approaches positive infinity. So as x approaches positive infinity, f of x approaches positive infinity, so it's going to be c. Alright, so that's part C, and that's what end behavior is. Alright, and then part D. So same function. This time it says how many relative maximums. Okay, now this is going to kind of go back to the second one that we did. Remember, we found that right here, f of x was negative, then positive, then negative, then positive. So basically what that means is the function was negative, then it went up, and it came down to 0, and it became negative again, then it went up again. Okay, so let me put that on this paper. So basically the function negative, positive, negative, positive, like that, right? Which kind of matches our end behavior, right? Goes up and to the right, down and to the left. So I think we got that part right. But relative maximum is a peak. So how many peaks are there? Just one. Okay. If it said minimums, it would just be one here. If it said extremes, then it would be both of them. So extremes are maximums and minimums. Alright, so that's number 13. Let me know if you have any questions on that, and keep working hard.